Hello everyone, welcome back to the Binary Tree Machine Learning AI course. And this is our week 6 lesson, week 6 topic of tuning the neural networks and using them for classifications. So let's go ahead and actually do a quick review of overfitting and underfitting. As we remember, overfitting, underfitting, and well tuning comes from when we have some training model and we make some sort of fit to it so that it makes some sort of prediction. And then we see on the testing set, is it good or is it bad? So if we look at like the training and testing mean squared errors, we want low minimized errors for both of these. If we see that the error is too high on one of them, we might need to change the model. And overfitting and underfitting comes from when the model's too simple or too complex. We need it to be well tuned. Now, remembering neural networks is for training a neural network, we set the weights randomly, forward pass to get a prediction. If the prediction is bad, then we calculate the loss. Well, we calculate the loss, see that it's bad, and then back propagate to adjust these weights to what we want it to be. And we can repeat this over and over again until we get a good accuracy. Remember, from many small dumb things, little neurons, we get one big smart thing. So now we're actually at week 6. We're using neural networks for classifications first. Let's think about that. So we've used it for regression so far, which means predicting a quantitative outcome like price of a home, but we also can use it for classification, like the logistic regression, like predicting a categorical outcome. Let's say the outcome of a soccer match or of a football match. Let's say in this football match, we have 3 outcomes: winning, losing, and drawing. Let's say we can make this neural network that will classify, that will take in all these inputs, have some sort of hidden layer running through it, and then outputting with 3 nodes in the output layer. Why are there 3 nodes rather than just one? Well, that's because the outputs are either winning, losing, and drawing. So taking in all of these input values, which is team record, player ratings, field weather, match result, home and slash away, all those kind of inputs, from there we go and look at the probability of each outcome, which is winning, drawing, losing. And we can use softmax, which is an activation function, to bound the outputs between 0 and 1. Just remember, main thing is we're trying to put the probability of each outcome between 0 and 1 so that once we get our outputs, we'll have some sort of value for them, some prediction probability to say, maybe there's a 50% chance of them winning, a 20% chance of them drawing, and a 30% chance of losing. Or maybe it'll be higher chance of winning or lower. So for regression tasks, let's remember we only have one output node because we're just predicting a number. But for classification, we have multiple, like 3. It could be even more because there can be many more than just 3 categories. Now let's talk about tuning these neural networks. So we've built the neural network, but how do we make it great? As we remember, we need to make it well tuned. But instead of adjusting polynomial terms like above, like we did before, we made it linear, quadratic, polynomial, we'll adjust number of layers and width, which is number of nodes per layer. So there are other things we can tune, but these are the 2 biggest things that we want to focus on. So let's think about these different choices. We of course have 2 choices. We can either make there be more layers, or we can make there be wider layers. Now, let's think about what is the danger of overfitting. If we make something very deep or very wide, what can happen is overfitting. An overly complex neural network can just memorize the training data, and then rather than learning the generalizable underlying pattern, it'll just overfit and only work on that one specific training set we gave it. Now, there are some things that we can try and use to minimize this, like there's something called dropout, hiding neurons, things like that. But for now, let's just think about how we use our training and testing set. What we do now is we can't just use one test set. We have to split up into many trials of test sets so that, and sometimes for real tests, we can run out of data. But what we do is we add a validation set. Within the training set, we have our training, and then we also have validation. So what happens is we while we're training and tuning, we use the original training set and train on that. And then we use validation to also test it within there. And then we keep that final testing set untouched until the final test. So we start fitting the model on this data on the training set, and then on the validation set, we test that model. And we keep doing that until we find a good model architecture. And then finally, when that's done, when the model is done, we evaluate the model predictions on the unseen test data, which is for our final prediction, to make sure that the model has not overfit, to make sure that the model can actually work on real testing data. So that was a kind of, this was a pretty similar process to what we did with our original regressions, but instead now on the neural networks, we have to train and validate as we go along and then have a final testing set that we evaluate our model on.